Hi everybody, my name is Christopher Collison and this is the second video in a series of videos addressing Burette calibration curves and the use of Microsoft Excel. In the last video we talked about the power of Microsoft Excel in being able to drag a series of calculations down through a column. We can therefore use the same formula against a whole set of different data, and this obviously saves a lot of time when we compare that to doing our calculations by hand. So Excel already is going to save us a ton of time in that regard. We also went through how you can use Microsoft Excel to do some simple statistical calculations. We recorded the average of a series of measurements. We also used the function approach to determine the standard deviation for a series of measurements. What we're going to do today is come back to building a calibration curve for the Burette. And we're also going to think about building graphs in Microsoft Excel and adding certain features to those graphs that are going to be particularly important for when you hand in your lab reports. So you'll need to include all of those features that I'll be describing today in order to get the maximum grade. So let's go take a look at Microsoft Excel, and we'll start from the point we left from in the previous video. Thanks for listening. So this is what we left ourselves with in the last video. We calculated the standard deviation and we calculated the mean for all of these values. We can also highlight these values in here in bold. And anytime we get the opportunity to tidy up our Excel spreadsheet, it makes it much easier for the person reviewing your work, and certainly makes it easier for you to get a higher grade. And it doesn't take much time. So the objective now is to plot a calibration curve. So we'll start to think about plotting graphs. We'll obviously have to think about our x-axis and our y-axis. So how do we pick an x-axis and a y-axis? The x-axis ends up being the known variable. It's the thing that we have control over, and the y-axis ends up being the measured value. So in this case, what we will have on our x-axis will be the expected volume that we actually dispensed from the Burette. And on the y-axis, we'll have the actual volume that was dispensed. So we'll set that up, first of all, in some columns so that we can work with those columns to easily set up our graph. So what we're going to do is we're going to write some headings. And again, headings are really important for the columns. It reminds us and helps us and allows us to see what calculations are going on for our own benefit, as well as for the benefit of the reviewer. So we'll call this first heading the Burette reading. That's our known variable. And I'm also going to show you something in Excel, how to start with a series, start with a single value, because we know that the Burette readings, of course, start at 10 milliliters, 20 milliliters, 30, and so on. So how can we do that using Excel? What we're going to do first of all is type in the first value for us, and this is 10. And then we're also going to go to the fill value up here, and we're going to click the menu item series. This opens up a new window, and we're going to tell Excel that we want to build a series with columns, and we're going to put in a step value of 10. Okay, so we know that we go from 10 to 20 to 30. The step value there is 10, and our stop value is going to be 50. How do we know it's 50? Well, down here is the largest volume that we've dispensed. Now we press OK, and what happens is Excel will fill in that series for us. Another thing we can do if we're looking at these particular cells in here is we can actually click on the number in here. So I'm going to click this number sign up here. In fact, up here I can also say what type of number I want in here. So this, at the moment, the default is general, so there's no specific format to the number. I'm going to select the number in here, and it's already set up in here to have two decimal places. If we want to look at that in more detail, We can also click here on the number value, and we can select the number of decimal places. In here I could actually go up to 7 or 5 decimal places. I think 2 is just fine, so we'll select that in here. We go OK. What about the Y values? I'm going to title this heading as the volume delivered. We might also call this the actual volume delivered. So we can choose anything we want as long as it conveys the appropriate information. And now what we're going to do is we're going to take those mean values. So we're actually going to copy and paste these values. At the moment, if I copy and paste this cell, for example, into this cell over here, I'm going to pull out a number of 0. What happened just there? Well, I've actually copied the formula across. So the next thing I want you to think about is how we might value paste something. So I'm going to now press Control C. That copies cell F11, and I'm going to paste in here. Looking over on the left hand side, I'm going to paste for values in here, and when I click that value, that has accurately carried across the mean value from our 3 trials. I'm going to go ahead and use the same approach to fill the rest of these cells. What you'll also notice is that when I value paste, the format of the cell into which I'm sending the data governs. Whereas the first time I copied and pasted, what I did was a general copy and paste, and that copied the formatting as well. So if I want to actually look at the cells in here and look at the format, and I can change that format, I'm going to click the format heading in here, and I'm going to go to the bottom here and open up the format cells window. And you've seen already before the number. I can change the number in here. At the moment we've got 4 decimal places in this particular cell, but I'm also going to look at the font in here, and I don't want to have a bold. I want this to be regular, so I'm going to change that back to regular. But I'm also going to make sure that the 4 decimal places are also available for the other cells in this column. So go back to number, we'll go up to 4 decimal places in here, and all those decimal places were carried across from the answer to the formula that we had in column F previously. Last of all, I'm going to put in my standard deviation, and this is going to help me put in my error bars later in the graph. So again, I'm going to demonstrate that if I copy and then value paste that standard deviation in here, that's the approach to take, and I'll fill that through. I'm using the Control C value in here, and then I'm going to use the paste function up here. Another interesting approach might be also to use the equals function. So if I press equals in here, and then I select the cell from which I'm taking that standard deviation value, this also works quite well, and therefore if I add some different trials and the standard deviation changes, then that will automatically update. In this particular case, it doesn't matter which approach you take, but I think this is also quite valuable to demonstrate the use of that equals function, so that if I change a number, for example, let's change this number arbitrarily to 49, and we'll see that the standard deviation value changed automatically in here. I'm going to then go back, by the way, and use the Control Z function to undo the change that I made, since that was an arbitrary change just used for the purpose of demonstration. So now I have, I'm going to make these column headings bold. I've got this is my X, and here's my Y, and this is going to be associated with my error bars. So now let's go ahead and plot the graph. I'm also going to remind you that it's always a good idea to save your file as often as you remember to. And I think it's worth saving every 5 minutes or so, maybe more frequently whenever you do an important change or whenever you make an important change to the graph. My my computer crashes quite regularly, and so the worst thing that can happen is you can lose all your hard work because you didn't hit the save button. So we can do this all the time, and that moves us forward. Now, before we go ahead and actually build the graph on the screen, I'm going to tell you about a particular tool in Excel that I think you might find particularly useful as you think about your lab write-ups. We're going to use something from the Analysis Toolpak in Excel to do a regression analysis on this data. How do we do that? So what I do is go to File, go to Options, go to Add-ins. I'm going to select the Analysis Toolpak option here, and then I'm going to press the Go button down here, and when I click on that, it gives me a list of options that I can bring into Excel. I'm actually going to bring in the Analysis Toolpak Visual Basic, and the Solver add-in. The Solver add-in we may find very useful for one of the labs that are coming up in this course. I'm going to go OK, and now when I click on Data, so I go from File to Data, what I find now is that I have a data analysis option in the top right hand corner. When I click on that data analysis option in here, what I'm going to do is I'm going to pick my regression analysis option here. So click regression and go OK. And I'm going to show you something here in Excel that allows you to do a higher level of statistical analysis of your data and actually provide that quantified error bar, the quantified errors for a particular experiment that you run. And it all is done within Excel. So there's less that you have to do on a piece of paper. So what we're going to do first is we're going to input the Y range in here, and I can select the Y values. Okay, and I'm going to press Enter. Select the X axis range in here, press Enter, and I'm also going to select a confidence level of 95%, and I'm going to have the results go into a new worksheet apply. And these are other options: residuals, standardized residuals, residual plots, and line fit plots that will be particularly more important when we have a large amount of data. For now, I'm just going to press OK. And what happens is I'm taken now to sheet 4, and here I see the output of the regression analysis. One other thing I can do in Excel is if I double click on the wall of a particular column, it expands that column so that the column fits the data that's within it. And at once, what we can see in here is we're given an R² value. We'll see this later graphically. We're also given a standard error, but I'm actually going to draw your attention to the rows here. And what we find here is we have a y-axis intercept, and that ends up being minus 0.0577. And the standard error is given for that coefficient. So if you think about the straight line plot, y equals mx plus c, where m is the slope and c is the y-axis intercept. So the error on the y-axis intercept is given as plus or minus 0.0337. We're also given a lower and upper bounds for that y-axis intercept. At the same time, here is the slope of the graph that we're going to see shortly graphically. Okay, so the slope is given as 1.0028. And the standard error is provided for us. So we can quote that standard error plus or minus 0.001. Okay, and we now have at the 95% confidence limit, so we're 95% confident that the lowest value that the slope could actually be from the data would be 0.999585, and the highest value that it could possibly be at the 95% confidence would be 1.006. So I'm putting this out there for you to think about, and you can ask your instructor about this, but I also think it's important just to know how to do it. So you select the y-axis values, you select the x-axis values, and the important thing here is that that standard error is provided, and you can use that quantitatively. At the push of a button, you can calculate it and use it in your lab reports. So this is sheet 4. We can also double click on sheet 4 and label it. So this is our error analysis, and we can put in here regression. Okay, and we can come back to sheet 1. We can even label sheet 1. Let's call this data. So now that we've returned here, let's start to put our graph together. So from the data menu item, we are going to click over to the insert menu item, and we're now going to select the cells that we would like to plot. We're going to include the titles, and we're going to select the x-axis and y-axis values, and then my recommendation is always to work with the scatter plot, and we're going to work with the scatter plot as shown, and we're even seeing a preview of those results. So I hit the scatter plot, and if you notice as I pick different options, it gives me a brief description of how to use a particular plot. We're going to use this version because we're going to put our own best fit line through this at some point in a few minutes time. What we might first notice is that there are no labels to the axes. So how do we set that up? We can choose different formats across the top of the screen, but I think the best approach to adding elements within the graph is to use this option on the left hand side. This will be your friend throughout your work in developing your graph. So first of all, we'll click on axes, and in fact axes titles will go to primary horizontal. So this is the burette reading, and we're actually going to include some units here. So this would be in milliliters. Having done that, we're also now going to add an axis title for the primary vertical, and we will call this actual volume delivered. And you put in the axis title that makes sense, and we put in the units that make sense. And I'm going to say that for the title, I want you to write a descriptive caption. So a calibration plot of the actual volume of water delivered as a function of the reading on the side of the burette. So we typically have a plot of y as a function of x. We can change the size of our plot. We can also change the number. So we can format the axis, and that allows us to provide, we look at the number, and we can also write in here the number of decimal places. So I'm going to actually put this as 0 for now. We're going to apply that, we'll enter that. That allows me to tidy up the graph. If you need to do something in Excel, it will be there. Sometimes the challenge is finding it. So sometimes we need to right click on a particular element, chart element, and we can format it through the window that pops up. The other thing we can do is, of course, as I mentioned before, use our friends up here on the left hand side, add chart element box. So we'll keep things consistent. We'll reduce this to 0. And this is just the labels that we're using. So it has no impact on the numbers that we're providing. It just gives an idea of it's just the labels themselves. Now the next thing we may choose to do is add a line, and we can do the same thing that we've done with the regression analysis from the add-in that I've just shown you. We can do the same thing in the graph itself, and what I'm going to do is I'm going to pick one of the points in here. I'm going to right click on one of my data points, and I'm going to click add trend line, and another little box opens up. We're going to do a linear trend line in here. We do not need to set the intercept, but basically we know that that intercept should be 0. So when that intercept is 0, when 0 volume has been delivered, we're going to measure 0 volume. We're going to also display the equation on the chart, and we're going to display the R² value on the chart. When the R² value is close to 1, we have an excellent fit. That means the line that we're putting in here, the equation for the straight line, fits the data perfectly when we have an R² of 1. So we're going to enter that, close the window, and now let's have a little look and see what we've got in here. We've got a legend now, and our legend in this case does have no intercept because the intercept is in fact 0. But the other thing we need to be able to do in here is we need to be able to change the numbers in that legend. In this case, we're going to select the format trendline label. When we do that, we just have to know what is in here. We have to be confident when we select that trendline label. What we want to do is change the format of the number. Let's put this in as maybe 3 decimal places. We'll add that, close the box, and see what we see. So now we're pretty much seeing that we do have a perfect fit, at least to 3 decimal places. And we've also got our calibration curve, and we're told that the slope of that curve is 1.001. If we want to format the trend line, okay, so let's remove the set intercept checkbox in here, and we'll press enter. And what we should indeed find at this point is we'll end up with the same numbers as we observed in the regression analysis that we did a little while ago. So now we have our graph. What we next need to do is add some error bars. How do we add error bars? What we're going to do again here is select the graph. We're going to click design, because in fact we're always going to find this add chart element menu item under the chart tools design menu. And then we're going to jump down here to error bars. What we're going to do is then go to more error bars options. And what we have to do is select the error bars. We're going to go down to custom, specify value, and the positive error bars we're going to select from our standard deviation column. The negative error bars we're also going to pick from our standard deviation column. Press enter, press OK. The problem with Microsoft Excel is that it defaults by giving a horizontal error bar often when you don't want a horizontal error bar. We typically do not have a horizontal error bar because these are our known variables. What we may need to do in this case is select them. I'm going to right click here and simply delete them. Since the vertical error bars are so small, it's so difficult to see them. I'm going to prove they're there, and I encourage you all to do this by changing the axis. Let's go from 9.8 to 10.2. And now we can see that that error bar is in there. It's so small. We're so confident of the values, but nevertheless we have that error bar in there. And that's the important thing, to recognize and to test and to check that you have your error bar. And you can always work with error bars using the add chart element menu item top left of the screen. Job done. We'll reset our axis values, and there our graph is complete. So now you know how to use Excel to plot a graph, to do a regression analysis using the Analysis Toolpak, and most importantly of all, you know how to use Excel to save you time as you're writing up your lab report. So thanks for listening. Good luck with the rest of the course.